Hello everyone, welcome to the second video lecture series on programmable timers. So let us move deeper into the discussions and its upcoming blocks. So you can see here the architecture and signal description. As in the last class we saw about the functional block diagram. So here now we'll move into the architecture and signal description into deeper. So a data busbar function acts as a bridge between the CPU and the timer. So when the CPU sends data like the initial count value or the control word, the data bus buffer receives and holds the 8-bit value temporarily so it can be processed internally. It is bidirectional, and the real-time analogy goes as think of it like a reception disk in an office, and when the messages are dropped off or picked up here, but only one direction at a time, just like in and out instructions. So coming to the read write logic function, this controls the direction of the data flow, that is read from or write to the timer. The inputs used are RD, that is the read signal. This is activated when CPU wants to read data from the counter, and WR is the write signal for any operation to be valid, and it generally ensures correct timing of read-write operation so that no data is lost or corrupted. Coming to a real-time analogy, imagine you have a filing cabinet. You can either insert document, that is write, or retrieve them, that is read. But you must unlock the drawer, that is which is the CS, that is the chip select, before doing anything, and choose the correct drawer which addresses lines. So the address lines are A0 and A1, and the function of these are that they are used to select one of the three counters. As you can see in the PPT, there are counters. There is a counter 0, counter 1, and a counter 2, and a control word register also. The memory mapped input output or port memory mapped input output addressing system of the CPU. So here when the bit is as 0 0, the counter 0 is selected, and when the bit is 0 1, counter 1 is selected, and when the bit is 1 0, counter 2, and when the bit is 1 1, control word register is selected. So in order to make it very clear, just think of a real-time analogy. That is, think of a vending machine with 4 buttons. The first 3 buttons, A0, A1 and the combinations, select a stop switch counter. The fourth button sets instructions for a machine. This is your control word register. So the counters as stopwatches, imagine you have 3 digital stopwatches sitting on your desk, counter 0, counter 1 and counter 2. Each stopwatch can be set to count down from a number, say 100. Once it reaches 0, it beeps. That's your out signal. So you can start any stopwatch independently. You can also read how much time is left at any point. So this is the read operation. So now moving into the selected operations for the various control inputs of 8254. Here you can generally see that the read-write operations is a programmable interval timer with 16-bit counter. These counters must be configured and monitored by the microprocessor using in and out operations, which perform read and write operation. First, set the initial count, that is the write operation purpose. Load a starting value into the counter. So this CPU uses the out instruction to write the count value. The count is loaded in 2 steps. First LSB, then MSB. This is done at the start of every timing cycle or to change the delay duration. In a room heater, you may want to turn the heater on for exactly 5 minutes. The CPU sets this count in the timer based on the clock frequency. Then read the current value. So here you can see that depending upon the types of mode, that is if the bit is selected as 0, 1, 0, 0 and 1, the counter 1 writes. And when the bit is set as 0, 0, 1, 1, 0, the counter is set to read. That is the counter 2. And when 0 0 1 1 1, no operation, that is it is tri-stated, it is said to be in the idle state. Or when it is 1, don't care, don't care, don't care and don't care, it is again disabled, or it can be said that it is in tri-stated condition. So here you can see the control word register, which is a 8-bit control word register, and the operations of the control word register are such that the D7 and D6 bit are used to select the counters, which is SC1 and SC0, counter 0, 1 and 2, and 1 1 it cannot be used. And RL1 and RL0 is used for latch counter, and 0 1 becomes the read load for the least significant bit, and 1 0 becomes for the MSB, and 1 1 becomes LSB first and then MSB. And M0, M1, M2 is used to select the various modes. You can see here, starting from 000 to 101, there are 6 different modes which can be used to select the different types of mode setting. And BCD operation is 0 1. If it is 0, it goes for hexadecimal count, and when it is 1, it goes for BCD count. And in the upcoming classes, we'll see about the forthcoming sessions and other things. Thank you.